Hello and welcome to day 11 of building a campus network. And in this very short video, we are going to configure a routing protocol on core switch 1 for VLAN 10 so that devices in VLAN 10 can hit the gateway. And we're also gonna do the same configuration on core switch 2 so devices on VLAN 20 can hit the gateway and therefore we get access to internet. So at the moment, this is PC1. If we try to ping the gateway, which is 10.1.100.253, we can't ping the gateway. So let's check to see the IP address of the gateway. The interface pointing to our network. So show IP interface brief shows me this is the IP address, of course, which the IP address of our gateway, but PC1 can ping the gateway. So now let's go ahead and configure routing protocol on core switch 2 and then core switch 1 respectively. So I'll choose EIGRP, config T, and I'll choose router, EIGRP, the process of 100 and network, and I use 10.0.0.0. Here I'm trying to perform a variable length subnet mask. Why? Because let me show you something. All the IP addresses for the respective VLANs are in the 10.0.0.0 network. So respectively, when you do a variable length subnet mask, we are going to get something like this because all these IP addresses fall within this network range. Thank you. So network 10.0, no auto summarization, and I'll exit. And so I'll go to core switch 2, and when I'm done configuring core switch 2, we should get a confirmation of neighboring adjacency from core switch 1 100. So network 10.0, same applies on core switch 2, no auto summarization, and as you can see, we have the adjacency formed. So show IP EIGRP neighbors shows me the neighbors. Same applies on core switch 2. Show IP EIGRP interfaces shows me the interfaces connecting, and as you can see, we have our interfaces connecting for EIGRP from a neighboring switch, which is core switch 1. And as you can see, same applies here. Let me maximize it a bit and type it again. So as you can see, we have the IP address 20.11 10.11, which happens to be on core switch 2. Same applies to the VLAN 1 interface on core switch 2. You can see the uptime and the runtime. You have a sequence and a count. So now, what do we have next? We have to get devices in respective VLAN talking to the gateway. So we go on to the gateway and also configure a routing protocol. So router EIGRP process of 100, and here we advertise only one IP address on the network. So we advertise 10.1.100.253, which is the IP address of the gateway pointing to our network. And here I'm going to do an inverse mask because EIGRP support inverse mask. So I will type 0.0.0.0, which specifies that the IP address must match the exact IP address we have here for advertisement of that protocol or that network. So and then go to summarization. As you can see, we already have adjacency being 4. So now that route has been exchanged, so show IP route. So now that route has been exchanged, and as you can see, we have the codes for D, which is EIGRP, and we've learned about VLAN 10 connecting through interface 100. Same applies to VLAN 20 over there. and they are all coming from Fast Ethernet 00. And we also have a static route pointing to the gateway. Okay, so back on core switch 2, show IP route. Shows me the routing table for core switch 2. And as you can see, we have L for local, C for connected, and we, as you can see, the various networks that has been named over here. Okay, so it's now forming the adjacency with core switch 3. So once again, show IP route shows me that that's learned these networks, and as you can see, okay, so EGRP neighbor 10.1.253 new adjacency on VLAN 1 is up. So show IP EIGRP neighbors. Oh, okay. Show IP EIGRP neighbors, and as you can see, we have VLAN 1, which is pointing to core switch, the gateway. Same applies on core switch 1. Show IP EIGRP neighbors, and as you can see, VLAN 1, we have two VLAN 1 appearing. One is for core switch 2, and then one is for the gateway. So back on core switch 2, show IP EIGRP neighbors, and as you can see, we have 10.2 and then 10.1 forming the adjacency. So now we should get PC1 and then PC2 talking to the gateway. At first we couldn't ping, but now we should be able to hit the gateway, and as you can see, we are now talking to the gateway. And there we go for PC1. So let's try that on PC2. So back on PC2, let's ping the gateway, which is 10.1.100.253. Post not reachable. Oh, sorry. Okay, let me try it again. Okay, but PC1 is able to ping, so I don't know what's wrong. Let me shut down PC2 and bring it up again. So stop, start. Okay, so once again, let's try to ping the gateway 10.1.100.353. Okay, so let me try the ping again. It should work. Yes, and now it's working. I think I had a problem with GNS3. I don't know why, but at times it does that. So now we're able to ping the gateway from respective VLANs 1 and VLAN 2. So this is PC2 talking to the gateway. So once again, I think it has went out. GNS3 is behaving very bad. So let me try on PC1, and as you can see, PC1 is able to ping the gateway, and I think the problem comes from the core switch. The EIGRP adjacency, it goes down and it comes back again. I don't know why, but I'm sure it's a problem with GNS3, but because it's supposed to work. Same configuration on core switch 1, and PC1 is able to talk to the gateway, so PC2 should be able to do same. As you can see, it has went down again, it has come up. So thanks for watching this video, and in my next video we are going to see how to get PC2 and PC1 in respective VLANs talk to the internet. Thanks for watching this video, and see you in my next video.